והמרצה הבאה, לין דיקס, שהיא מאותה קבוצה של ביל, בעצם יד ימין, יש לו הרבה ידיים, אז אני לא בטוח אם זה ימין, ימין ורבע, אבל מקדמת נושאים דומים. עכשיו זה מעניין לראות שהיא עמיתת מחקר במועצה למחקר הסביבה הטבעית. באנגליה יש דבר כזה, אפילו שהסביבה הטבעית, כמו שאמרנו, היא לא בדיוק טבעית, אבל היא מספיק מטרידה או מעניינת את הבריטים כדי שהם ישקיעו בה הרבה יותר ממה שאנחנו עושים. ובעצם מה שלין מנסה לעשות זה למצוא את הקשר המעשי, evidence-based, בין המגוון הביולוגי ושירותי מערכת, הרבה מאוד מזה במערכות חקלאיות, כי היא מתמחה במאביקים. It was a brief summary of what you are doing in Hebrew. I hope you will approve it.
Thank you very much. So I'm actually going to talk about one specific example of how you might use evidence assessed in the way that Bill has described. And this is not so much about policy, which Bill has talked a lot about, more about environmental decisions in business and in practice, in agriculture. First, I'd like you to think about the way in which environmental decisions are made and about the people who are making them. So here are some different types of people making different types of environmental decisions. Have I got a pointer on here? I'm going to try it. No. It doesn't matter. Yes, thank you. So this chap is a European agriculture minister from one of the member states, and he's there making a decision about the common agricultural policy reform, which happened in 2013. Here's someone making a very different kind of decision on a farm, perhaps thinking about what crop to plant. Here's more of an office-based accounting type decision going on. You have people perhaps using a computer here. This is a decision point which we may all share. This lady is deciding what to buy. But that's also an environmental decision because the food she buys and the food that the millions of other people buy affects the environment quite massively. And here perhaps some foresters deciding what tree to chop down. So all these different contexts, I would call them decision-making contexts, which affect the environment. I'm going to talk to you about a decision support tool, so I thought I'd start by explaining what I mean by a decision support tool. Here's a definition on the table for you to start with. You might think it's a tool to assist decision makers with a particular decision, often by illustrating different possible outcomes or by leading users through logical decision steps. Going back to our decision makers, perhaps you can see that some of these people are using decision support tools. In fact, this man here might be himself a decision support system. He's an advisor. He's helping this guy make his decision. Perhaps, here again, one of these people perhaps is a businessman making a decision, the other one is their accountant who is advising them. These people are using a software system. This lady here, she's using a different kind of decision support. She's probably, maybe, she's reading the label. And the label is a piece of written guidance which will give her some information that helps her. She might be looking at calorie content. She might be choosing organic food. So she's using like a paper-based guidance system to help her decision, all these different elements that could support your decision. There's actually only one person really on there who's making a decision without a decision support system, and that's this lady. So why would I be interested in decision support tools? Now I'm going to show you something you've already seen, but I'll give you a little bit more explanation about this. This is something we published last year, and it's a way of understanding how you might organize environmental evidence. It's a hierarchical framework, if you like. And at the very bottom of this, and the triangle shape just represents really the scale of information at the different levels, the number of different sources you might find. So at the bottom here, you have scientific investigations, and there are hundreds and hundreds of thousands of them. And they're quite difficult to find, and there are just many, many different studies for a particular problem that you might be interested in. Say, for example, you're trying to work out how to manage your forest. The next level up, systematic reviews, you may have heard about systematic reviews. This, for me, represents a very rigorous method and approach to bringing together and understanding what the scientific studies say for a particular question in an unbiased way. So this is not, these are the studies we know about, this is what are all the studies and what's the full clear picture without any bias. And the way you get no bias is to have an approach to finding evidence which is decided before you start and is also itself peer-reviewed. So you have to publish your search protocol to do a formal systematic review, and then you do the search with a set of advisors. So it's a very rigorous method. And at that level, many people who think about evidence-based decision-making would stop. We're happy, we've got a systematic review, we know the answer now. But in fact, if you're making a decision, like the people we saw at the beginning, you don't just want to know the systematic review that tells you the answer for one particular option. You need to see what the evidence says across all your possible options. In your forest, you don't just want to know the effect of logging in a particular way. You want to know how that compares with the cost and effect of not logging that forest at all, for instance, or taking out this particular kind of tree only. There's lots of different details behind that you might want to know. So that's why we've been producing this level, which we call summaries, and this is the same as some of the books, that were the conservation evidence books that we've been publishing. And here you have understandable, concise descriptions of the best available evidence in a whole area of practice, and preferably with recommendations. I should say that this whole way of thinking, like all the best ideas, is not ours. It's borrowed and adapted from evidence-based medicine, where you also, a hierarchical framework of organising evidence has emerged over time, and it's starting to emerge for environment. But once you've got to the summary level, you can see what all the evidence says, you can understand the science more easily, even if you're not a scientist. The final level of this is the decision support systems. And here is where your decision makers come in. So you might have tools or guidance to help with particular decisions in a particular decision-making context by illustrating the outcomes, for instance. But what matters to me is that this level, where the decision makers are using the evidence, links through directly and clearly, transparently to this level, so that we are properly representing the scientific knowledge we have. That's why I focus on decision support systems. So my question for the last couple of years is, how can a decision support system incorporate summaries of evidence? And I think I've found a way that I'm going to share with you today. It's one of many possible ways, I'm sure. I only know of one other decision support system that has even tried to use unbiased summary of evidence, and that was in a paper published last year which clearly demonstrated that the decision support system was better because it incorporated the evidence than when it had not. So I've got high hopes for this approach. I've been working with an organisation called the Cool Farm Alliance. They are a partnership, actually an NGO, a small NGO, but a partnership of some very big agri-food companies and businesses. The likes of Heineken, Unilever, Marks & Spencer, some big agrochemical companies. They've been working together and they've come together to own and use a tool which is basically a sustainability metric for farms. And it's called the Cool Farm tool. At the moment, if you look online, here's the website, you'll find a greenhouse gas calculator for farms, because the Cool Farm tool emerged from a system that measured greenhouse gas emissions according to your farm practice and the crop. Oh, sorry, I've pressed it by mistake there. According to the farm practice. And this is used in some pretty big supply chains. It's been used, for instance, by Kellogg's to make an assessment as to whether it's a good idea to continue growing their cornflakes in Argentina, which is where they're mostly grown, or whether they should move the production to Spain, and how that looks from a greenhouse gas perspective. They use the Cool Farm tool to make the calculations. Surprisingly, they find that it's better to continue with the Argentinian corn production than to move it to Spain, because of the farm management, because of the way the soil is managed in Argentina, largely. But until you do those calculations, you don't actually know what the answer is, and that's why it's a decision support tool. There was a decision, this is what we found, having done the calculations in this piece of software. The Cool Farm Alliance are very proud of the Cool Farm tool because it's scientifically robust. It's also farmer friendly. A farmer can run through this system and get an answer without having to be a scientist. And of course it's industry backed, which gives it the power to roll out its approach across many, many farms all over the world. These businesses are not based, they're multinational businesses, and they have supply chains that are global. So the first, once the Cool Farm Alliance had been formed around this greenhouse gas calculator, their mission was to expand the Cool Farm tool so that it would measure other things, other aspects of sustainability. And it now has some new calculators under development. One is water, one is looking at water footprint, and one is looking at the economics and how the different farm practices affect the farm business, and the tool I'm working on. This was one of their priorities, biodiversity. So, how do you measure on-farm biodiversity? I imagine most of you in this room will realise that this is quite a challenge. I think there are two different approaches to this. I should say first, on-farm biodiversity is by nature very complex. There are many different ways there are many different aspects of biodiversity. Birds, I put dragonflies, flowers, habitats, genes, worms. It's a very mixed picture, lots and lots of different types of organism involved. So how do you measure it? You can either decide to actually measure the biodiversity, which I would call an outcome-based approach. You go out and you count the animals and you count the plants on your farms. Or you can measure proxies for that. So again, you're counting, but you're counting, say, habitat diversity, or the length of the area or length of different types of habitat. And that gives you some indication of what biodiversity you have. And this has been the most dominant approach to managing on-farm biodiversity and measuring it, I would argue. I would call it difficult, but at least you're sure of the outcomes. And when I say difficult, I mean astonishingly expensive and pretty impractical, really, from a commercial farming perspective. And the other approach is to take an action-based approach. And here, instead of measuring the actual biodiversity, you measure the things that the farmer is doing that you would expect to help biodiversity. So then you can measure how much agri-environmental management there is, which and how many specific interventions the farmers are doing, and what's their general approach to farm management. How do they manage agrochemicals? What kind of tillage do they use? Now this is, in business, has been the approach, because this is easy. It's easier, and it's easy because most farmers already know the answer to these. They already have the data. They know what practices they're doing very well. But the problem with it is that you're quite unsure of the outcomes. It's very uncertain. You're then assuming that the agri-environment options you've selected that you count are actually beneficial to biodiversity on that farm in that place. And ecologists will know that the actual effect depends on the landscape around that farm, and that it very much matters how well you do that action. So there's a lot more complexity. So here you're unsure of the outcomes, but it's an easy thing to measure. Now, there was a pre-existing tool which the Cool Farm Alliance had already selected as the tool it was going to use to measure biodiversity. It was designed over a period of years with farmers very much involved in the design by a consultancy in the Netherlands called CLM. And it's called the Gaia Biodiversity Yardstick. And it has a series of questions which are all about what practices are happening on that farm. And you just tick the boxes for the things you're doing, and you get a score, which is effectively the number of things you do. It's a very simple tick box exercise. So it's in my easy but unsure of outcomes category. At the same time as that was being developed, as Bill has already discussed, in Cambridge we've been doing compiling scientific evidence for the effects of different interventions. And we've covered farmland management actions for Northern Europe. We've also looked at a whole range of things now. You'll hear more about this, but here are some examples. And in each of these, we've gone through all the different actions you could take, and we've pulled together all the evidence and summarised it in plain English so that it can be easily understood. And then the next stage of this was to make an assessment of that evidence so that you can put the interventions into categories. I'm going to try again with the pointer. I'm not very good at this. based on effectiveness scores and certainty scores, which I'll talk a little bit more about in a while, arrived at with groups of experts using the Delphi process, which you now know is a much more effective way to use expert opinion than just simply asking experts what the best thing to do would be. So we had that as a pre-existing resource. The expert assessment process we follow involves experts from research, from NGOs and from industry, a smallish group in each case, maybe between 8 and 10 people, and those people read the summarized evidence in these books we've been showing you, and then they go through several rounds. They score and comment on whether this is effective and how certain we are for each intervention, based on the evidence. We actually have 2 rounds of scoring, so they all score independently and anonymously. Then they will see everybody else's score, and they will look at the scores and look at the comments, decide whether they want to stick with it. It's a bit like poker. You can stick with your original score, or you can, what's the word? Twist? I can't remember. I don't play poker. Or you can change your score to adjust to meet other people's because there's something you hadn't thought of, you'd misunderstood, so you can change your score. And then the second round of scoring, we then put the interventions into these categories. Very simple, crude, likely to be beneficial, beneficial, unknown, unlikely to be beneficial, or likely to be ineffective. And if people see the categories and they disagree, we then give them a chance to rescore. But they can't just move the category. They have to go back and read the evidence again, and they have to rescore each individually and anonymously, and then we'll go through the scoring again and put the category again. When we've done this in the past, there are some things which people really don't like the assessment. They disagree with the category, but you make them look at the evidence, and what they see is that although we all want to believe this works, we really want to, the evidence doesn't support this. So we have an assessment that's based on the evidence and not on what people thought would be the outcome. So in our decision support tool, we've simply brought these things together. We put the University of Cambridge evidence assessment with the CLM Biodiversity Yardstick. And we've come up with a tool that we call Cool Farm Nature, and this is action-based, so it's easy to do, but it relies on evidence of outcomes. It's not as good as having measured on individual farms, but it's a long way towards that. Here is an explanation of how we come up with the categories. If you have scored for no negative side effects or adverse effects, you've seen this before as well, you can just simply plot them on a graph with effectiveness score after the 3 rounds along here and the certainty score up here. So what you want to do is be supporting the things which are very effective, and we really know that they're effective. There are loads of studies, they're replicated, they're in lots of places, they all show the same thing. The things over here, they show a very low effectiveness score, but high certainty. We've got loads of studies, they all show this doesn't work. They come out in this category, likely to be ineffective or have adverse side effects. And we put a threshold here on the certainty. If it's less than, if after several rounds of scoring the general assessment is that it's less than 40% certain, it just goes in an unknown category. We're not confident enough about this evidence to put it in one of these categories, so we're going to say it's unknown, and we'd like some more research, please. If there has been a score that shows there are adverse effects of the interventions, then we replace the beneficial and likely to be beneficial with a trade-offs category. There are trade-offs here between benefits and harms, and in that case you would want the decision makers to go and look at the evidence and think about the trade-offs. So what we've done is put these scores into the tick box list of actions in the biodiversity yardstick approach, and we've simply weighted the scores. So if something is known to be beneficial from evidence, it gets 2 extra points. It's very exciting. 2 points more. If it's only likely, it only gets 1 point. If it's in one of these categories, it doesn't get any additional points. And if it's something that comes out as likely to be ineffective or harmful, it's excluded altogether from the tool. We don't want that one in there. And we've done this assessment not just for biodiversity as a whole, but in fact for several different groups of biodiversity that are of interest to farmers. For instance, beneficial invertebrates is one of the groups. Woodland birds is one of the groups. And for each of these different groups, we've convened a group of experts who know about that group, and they've done the evidence assessment just for their group. So looking into the evidence, what do we know about the effect of this intervention on woodland birds? What do we know about it for arable flowers? Annual weeds that would grow in crops, for instance. So we've broken it down into different elements of biodiversity. This is what the tool looks like. It's currently in prototype form, so it's available to have a look at on this URL. It's got only 31 questions, so it's quite quick to do, and it falls into 4 components. We break the questions down into crop and livestock diversity, production practices, which are the things you do in your actual commercial farm management, in your fields, on your crops, the way you manage chemicals, the way you till the soil, those kind of things. Small natural habitats, which are your field margins and your small, very small areas of natural habitat, which a lot of farms do have. And then larger natural areas and landscapes. And when you've run through this tool as a farm, the result you get looks like this. We have argued against our partners, the Cool Farm Alliance, on whether or not there should be a single individual score. You just get one score, because they want just a score. They just want to know what's the number of points out of 100 for biodiversity for this farm. And we prefer not to do that. We think that it's A, more interesting, and B, more scientifically defensible if you have the separate components and you just have a score for the different components. But what we present is a percentage. And this is the percentage of points that you have of all of the possible points you could have had if you did all the best things for biodiversity for each component. But what you also see in the result of this piece of software is how your score breaks down for the different components of biodiversity that are of interest. So you get, again, a percentage score for arable flora, for woodland flora. You get a different score for soil fauna. So you can see how you're doing on all these different areas. Now, the way we've built the software, these are completely flexible. You could, this currently the evidence base is just for Northern Europe. So we have a set of questions that apply to Northern European farmland, which is, obviously it covers a lot of things, but it doesn't cover Southern European farmland, for instance. It doesn't cover the tropical context at all. And the questions are relevant to that. And the taxonomic groups are also relevant to that. They're the things that might be important to farmers in this part of the world. We hope very much to build another tool which applies to a different farming biome, and it will have a different set of species groups and a different set of actions in it, with, again, the evidence underneath. And the final thing you get is a breakdown of how your land use looks for the different natural habitats. The next step with this, so here you just see how much of your nature-based management is grass and flower, how much is woody, how much is in-field nature agreements, and how much is wet habitats. My current project is to change that, so you don't just see the nature habitats, but you see them as a proportion of the total farm area. It's more difficult than it feels like it ought to be to get to that. But for me, the interesting information here is what percentage of the farm is given over to nature management. So we're moving towards that. And the reason this is useful and a decision support tool for farmers and for companies who are managing big supply chains is that it can tell you, how can I improve my score for biodiversity? What could I do on this farm? Which of the actions could I take that would boost the score? Perhaps for the species groups that I'm interested in. Perhaps if you grow an insect-pollinated crop, you might be interested in boosting your score for beneficial invertebrates. Or you might really be in an area where woodland birds are very important. You might want to boost your score for woodland birds. But it also allows the companies and the farmers to compare their score with other farms in the same region. Thank you. So that's a kind of benchmarking exercise that we will be able to do once this is rolled out. So I'm just going to finally tell you about where we're going with this. This is at a very early stage. It's still a work in progress. And here is my plan of the future. I'm thinking quite long term, up to 2025 here. The first thing that is going to happen is that the tool is being tested in a few Northern European countries, just piloted to see how it goes with growers, to see how well it works and how easy it is to use by real farmers and real farm advisors. And this is being done by three companies, actually: Kellogg's, Unilever, and a company called ADAS, which used to be the Government Advisory Service, the Government Extension Service, or part of it, in the UK. Next spring, this is happening. I also have a project which has just been funded by the Nature Conservancy California, which is paying somebody to do the evidence assessment, the first bit, all of the actions and what the evidence says, for Mediterranean-type farmland. And that's going to be a global exercise, so it's going to be Southern Europe, California, Chile, parts of Australia, bits of South Africa, all the places in the world where the best wine comes from. And this is looking at how you manage intensive farming in these regions. So it's things like olives and tree crops and vineyards. A bit further into the future, what we will hope to get, I'm sure we will get, is some very large data sets on how farms are managed for biodiversity. Because these companies that run the Cool Farm tool are big companies with big supply chains, as I said. So we will be able to see, we'll start to see which regions are doing really well, which crops are doing really well, you know, all over the world, which is very exciting to me because I'm a scientist. And again, in the longer term, because the Cool Farm tool is not just measuring biodiversity, it's also measuring greenhouse gas emissions, it's also measuring water. We'll be able to start looking on this global supply chain scale at the trade-offs between and among sustainability measures. Ultimately, by 2025, we're going to have improved conditions for wildlife on all the farms in the world. This is my hope. This is why I'm here. So I just wanted my final slide is a picture for you. And I tried to choose a picture which represents one of the Mediterranean-type crops that I'll be summarising the evidence for over the next couple of years. But in a context in which I would guess that the people who are eating it have not thought at all about biodiversity. This is one way in which you might consume olives. And what I hope that the Cool Farm Nature tool will do is that it will mean that those people who are consuming olives in their martinis on a Friday night can rest assured that the olives have been grown in a way that is better for biodiversity, because the companies who are bringing in the olives and buying them from the farms have provided an incentive to improve biodiversity management on those farms, have legitimised it as a thing that farmers would do, and have made it easy for them by providing the evidence and giving them an idea of what they should do that would improve things. So that's the end of my talk. Thank you very much for listening. I'd like to thank you. All these people here are the people who took part in the evidence assessment for all the different species groups when we built the Cool Farm Nature tool. So I need to thank them all. Thank you very much.